is I just need you guys to pull up some of it. So squeeze the bulb of your pipette, and I want you to put it in your liquid. Your liquid is right in here.
That's acetone.
That's acetone. And so pull up a little bit of your liquid into your pipette, and we're just going to place a couple of drops of your liquid. Oh, okay.
What did I do?
You squirted all over the place, is what you did.
Touch it.
All right, so let's get another.
I'm sorry.
It's okay. It's all right. All right, so here we go. All right, I'm going to get this out of the way.
One foot by 1 foot sheets.
Okay, here we go. So we just want a little bit. Here we go. So there's some acetone.
There's some water.
Okay, some water. So there's acetone. Here's water. Okay, and then rubbing alcohol. There's our rub. Is that the rubbing alcohol?
Yes.
Yeah, do a little bit more. Okay, and then let's do this is our vinegar. Okay, now.
Water is the strongest.
Okay. So, question, you guys. Which property of a liquid do you think I'm illustrating here? Surface tension. This right here is all about surface tension. Okay? The stronger the attractive force is, the higher the surface tension. Okay? So what we see with, this was water and this was vinegar, am I right?
Yep.
Okay? So what we see with the water and the vinegar is that those droplets actually beaded up and kind of turned into these beautiful little spheres. Do y'all see that? Okay? Whereas this liquid and this liquid, this was the acetone over here, and this right here is the rubbing alcohol. Those liquids actually spread out more on the paper. Can you guys see that? Okay, so these two liquids have much lower surface tension compared to these two liquids. Okay, now, earlier, you guys, what did we learn about water in terms of its polarity? Water is very polar. Now, water, does it look like it's having a tendency to try to mix or combine with this wax paper, or is it trying to look like it's getting away from the wax paper? This guy is trying to beat up as much as possible to try to get away from the wax paper. Exactly. So this wax paper is nonpolar. Okay? So what we can see here is that the very polar water molecule has those very strong attractive forces to itself, and it has such strong attractive forces to itself that it's not attracting to the wax paper. Does that make sense? Mm-hmm. Okay, and the same with the vinegar, but it doesn't look like it's quite as polar. Does everybody agree? Its little bead is not quite as tightly packed together, but it is a nice little bead. Okay, these two really spread out. So these two liquids, they've got low surface tensions. What does that tell us about their attractive forces?
Low.
They're lower. So these two have much weaker attractive forces, and likely because we can actually see them trying to sort of spread out and touch the wax paper. Wax is nonpolar. What does that probably tell us about these two liquids? They're also pretty nonpolar, or at least much less polar than these two guys right here. Does that make sense? Okay, because things will mix with each other when they have very similar attractive forces, and they have a tendency not to mix with each other when their attractive forces are very different. Does that make sense? All right, so that, you guys, is number 6. Okay, we're looking at surface tension. Very good. Okay, I have one other just neat, y'all don't have to write anything down about